We have a tool kit that we use to determine the framing which exists behind sheetrock. I'm going to go over those with you. We use 1.5 inches per foot. Grid paper is my preferred scale because you can put down the details you want. And a pencil. And we have wires, 1/16 or so. These are common wires that you place in the ground like this. One of them is straight. A couple of them have crooks on the end. And you'll see that purpose later. And this is a protector so they don't get bent in this container right here. We have Franklin LED stud finder, which I think is the best type of stud finder. We have a step stool. This is a really industrial quality one, about $40, and it'll allow you to do 8-foot ceilings probably without having to get this one out. This is my stair ladder. I call it. It's a little giant, less than $150, and it is. I call it a stair ladder because there aren't really steps. There are stairs here. You got something to hold on to at the top. You have 4 steps. You can work off any of these steps. And you will also need some sort of folding ladder for higher ceilings. And this will allow you also to get your head up in a scuttle and be able to look in a attic above the joist level. We also have stickers in a cigarette case. We have a magnetic wand and push pin magnets, and you'll see their utility later. And just so they don't stick to everything, we put it in a vinyl tube. And there's some more push pin magnets. We have the Zircon stud finder. You notice the blue light as it comes on. You'll see the utility of that later. Flashlight, thermal imaging camera, a pin punch. This is a hardware handle. This is a 1/16 Allen wrench, which has been ground down, and the length is kind of important. You want it about 0.7 inches long, 3/4 inch long. We have an X-Tech penless moistometer, tape measure, LiDAR. This is measuring somewhere here. A heat lamp for advanced work, along with the LED. Digital camera, and a portable drill with a 1/16 inch drill bit. To show the process of detecting structure underneath sheetrock, obscured structure, we have 5 wall sections, panels that we're going to be using our devices upon. All right, we're going to start with panel A. This is a wall section, which is made up of 2x4s, a couple of 2x4 studs in here, really, but they're going to act like joists in this case, and we have sheetrock over it. So the go-to stud detector is a Franklin. It's about $40, $50. We go ahead, and if we know no better, we start off in a certain direction. We should be looking for 3 LEDs, which would indicate 2x product. We're not getting anything like that. So we start off in the other direction, and we have 3 LEDs here. We're going to mark that with a sticker, and then we come over and we have another, and we can confirm it by going up and down. We do have a joist here, and if I measure that with the tape measure, I know I have up and down joists, and we're at 16. still on panel A. We have sheetrock screws, which we know are the fastening of the sheetrock to the studs, to the joists. We're going to use a magnet wand right here with some strong magnets here, and we are going to then be able to put a push pin at that point. These are push pin magnets. So if we were going to use magnets as the finder, we have one there. Instead of using the Franklin, we could also find the joist by using the metal, by using the magnet right here. Got one here. So that the joist, if it were running that direction, would be very close, and we're not going to find any magnets here. Okay, so we know that the joists are running this way by using a magnetic wand. We can also use this right here, the zircon. If it comes into contact with some metal, it'll get have a blue light show up. So we see if we see anything else right here. We do need to get a push pin. We're going to find some additional screws by using this here. So we're getting a blue light there, all reds. So we have a screw there that we do. Let's see if we can find one here. So we can kind of go over the whole thing. It's lighting up blue. We can pinpoint it with this. We got the blue there. That should be. So that's the magnetic method. We can either use the wand or the zircon to find the attachment sheetrock screws. Now we're going to go ahead and see if we can find the depth of the stud. So we know it's here. We're going to use this pin punch right here, and we did this already. So we find this hole right here. You see that we are not all the way down here, but we are all the way down here. So this is the edge right here. We're going to make a inverted V shape right here. Okay, but normally you would just go in first with the first hole. So we're going to go in, and if you're on a second, if you've got a floor above, you would expect to go ahead and hit something. Okay, but if we come in here with this right here, we're not going to hit anything because we know we have a clear back. Okay, but let's say we're at an attic, and so what do we have there for a depth? We go in there with the crooked end right here in the inverted V. We go ahead and we try to find, and we haven't found it yet, but okay, right there we feel the the joist. We're going to call it a generic joist, and we measure here. We've pinched it. We're 4 inches. We have ½ inch of sheetrock, 3½ inches. It's a 2x4. Okay. Okay, we're still on panel A. I'm going to show you some of the difficulties that you might have in certain cases. If you have foil backed bat insulation, so I've got aluminum foil down here, you will see that you're not going to get a very good signal, and so magnets would be the way to go probably in this case. And over here, to simulate popcorn or a large buildup of mud, I have a terry towel right here. We can see, even though we know we have a joist right here, we're not going to pick it up. We also wouldn't pick it up with magnets either very well. All right, we're on to panel B. Panel B is the same makeup as A. It has a 2x4 framework with sheetrock overs, but no sheetrock screws. So if we use the zircon to try and search for any metal, we're not going to see any blue light showing up right here. This is an unusual case. The Franklin woodwork, Franklin would be right here, showing right here we have a joist here, showing we have a joist here. There is another device I want to introduce you to. That's the X-Tech pinless moisture meter. It also is very effective at finding difficult structures. So we turn it on. We're going to go ahead and calibrate it. Let's get a couple of stickers. All right, so we're going to go ahead and we're going to look at the numbers we're getting right here: 38, 40, 40, 40, 44, 49, 55, 64, 73, 79, 79, 76, 76, 70. All right, so we're getting a maximum reading right here. We come over here, expecting we're going to have another joist somewhere around here, 47, 67, 76. Okay, so we have a maximum about right here, looks like. Yeah, for sure. 36 or so right here. So we find the direction of joist also by coming over here and seeing where the maximum's going to be. 53, 53, 47. So we have a maximum here. Let's see if we have a maximum here to see if the joist is going that direction. 32, 32, 29, 29. So we have no maximum here. So the joists are running that direction by using this instrument here. All right, here we are in panel C. Panel C are 2x8 framing, and we have 1-inch material simulating shiplap. You see this on over houses, and it becomes very difficult to characterize the framing. But there are methods. And so if we go ahead and try and see what the framing is, we try and use our trusty. We actually are getting something. It may be it, but you see you have a lot more. There you go. It's going crazy. You just don't get good feedback with the Franklin. And if we use the magnet, we'd see way too many spurious things because people would attach the shiplap to the framing, then attach a sheetrock to the shiplap, and that would be at a random place. So we just wouldn't find anything that make any sense with that. So we go back to our X-Tech again, and we're going to go ahead and turn it on. We're going to calibrate it in air. And then we're going to be trying to find where we have our maximum. 94, 88, 88, 88, 88, 94, 94, 100, 106, 112, 126, 126, dropping off, 135. So we put a sticker there. That would be our spot. And come over here, we got 88, 100, 94, 94, 97, 100, 106, 114, 118, 118, 114, 112. So we're about at 118 right here. And we would then, to try and find, so we have two joists here. We don't know if that direction or this direction. And so we go ahead and look at our maxima here. 106, 112, 112, 112, dropping to 108. So it appears that they're in this direction. And let's see if we get anything in this direction. We got 94, 91, 91, 88, 88, 88, 88, 91, 94. So the joists are running in that direction. Here we are in panel C. I just want to show you, we have shiplap here. There's no way you're going to get through this with the pin punch. You have to, this is where your drill is going to come in handy right here. You can drill it through, and then you can stick a wire in there and get the side of the joist. right, here we have panel D. Here we have a 2x4 perimeter frame, and we have different sizes of joists in this case. And we also have this backed up by sheetrock on the back side as if we had subfloor for a floor above. We're going to go ahead and check right here, see what the Franklin's going to give us. We have the typical 3 LEDs right here. That's a 2x. Right here we know we have a 2x and a 1x, but it's showing up as a single 2x because, I guess because of 2 different lumbers, it's still going to show as 1. Typically if it was 2 1/4 inch material, we'd have 4 LEDs. But that's the weakness in this test, I guess. And over here we see 6 LEDs, and it's positively 6 LEDs. And so this would indicate a broadside 2x4, such as on an open web truss that's built out of 2x4s. So if we are going to, we have our joist approximately this position here, and we are going to use our pin punch to find the edge of the joist. Actually, you don't even have to do that. Right here, even anywhere between here, we would tend to see that we have, we don't have any joists, and we can use a punch right here. We hit the subfloor above, go and pull this out, and we're going to measure it at 4 inches, subtract a 1/2 inch for the sheetrock, 3.5. These are 3.5 inch or 2x4 joists. Okay. All right, here we are again on panel D. We have the 2x4, which is wide right here, but let's say we are not sure, we really want to make sure it is that 2x4 and not something which has some size near it. And so I've already pre-punched these holes right here, but we know we have this broad area here. We're going to punch, and right here we hit wood because we don't penetrate all the way. Right here we hit wood again, and here we don't. We mark that with an X. Over here on the right side of it, we're going to go ahead and push right here. We go all the way down. Over here we hit wood. Over here we're all the way down too. And so we mark that with an X too, and an O would be in this area, and X would be at the outer limits, and we can see that it's 3.5 inches wide. Here we are in panel E. Panel E has a lot of confusing structure here that would be difficult to, by the normal methods, figure out. We can try with the Franklin right here. We can see we're getting crazy stuff right here, getting this right here, but it's not in an orthogonal direction, not in an orthogonal direction. So I don't know what's in here. So we're going to have to use an advanced method here. Cut. Okay, we're still in panel E. The advanced method is that we artificially induce a thermal gradient into the wall by use of a heat lamp. So we're going to run this for about 3 to 5 minutes. Okay. All right, we're at panel E. We've done a heat lamp inducing artificial thermal difference into it. We can see that we have a vertical, we have a horizontal, and we have some sort of diagonal structure here. And you can kind of pick out the screw heads there. They usually show up really nicely, so you can pick those out. Okay. The thermal imaging camera has a lot of use on exterior walls and sometimes on interior walls and ceilings. Here we are in panel D. Right here, we've done nothing to it, but we can pick out that it's consisting of some vertical joists here. Panel C, even with the shiplap, we can still pick it out. Okay, we didn't heat these. Panel B, the same way. And panel A, also picking it up. All right.